Why is groundwater contamination hard to track? Imagine trying to follow a trail that disappears underground and moves at a snail's pace. That's what tracking groundwater contamination often feels like. Groundwater is hidden beneath the Earth's surface, flowing through underground layers called aquifers. These aquifers are made of porous rocks or sediments that hold water. The water table marks the top of the saturated zone where all these layers are filled with water. Because it's underground and not visible, spotting contamination directly is nearly impossible. Groundwater moves slowly, often just a few meters per year, depending on the geology. Its flow follows complex paths influenced by the type of rocks, fractures, and soil layers. Some areas have cracks or fissures that speed up flow, while others slow it down. This unpredictable movement makes it tough to know exactly where pollutants are heading or how far they have traveled. Monitoring groundwater usually involves drilling wells at specific spots to collect water samples. But these wells only give a tiny snapshot of the entire underground system. They can miss contamination that is spread out or moving past the sampling point. Since pollutants can travel long distances underground and change over time, periodic testing might not catch sudden spikes or the full extent of pollution. Detecting pollutants at very low levels adds another challenge. Many contaminants are present in tiny amounts, requiring expensive and sensitive laboratory tests. These tests are not always available or practical for continuous monitoring. Technologies that can track contamination in real time are still being developed and are often costly. The chemical and physical interactions between pollutants and the surrounding rocks or sediments can also make tracking difficult. Some chemicals break down or transform, changing their properties and making it harder to identify their original source. Also, the rates at which groundwater recharges and flows are often uncertain, which complicates predicting how contaminants move. Environmental assessments can help identify pollution sources by analyzing land use history, soil, and water samples, or using remote sensing. But these methods requiring a lot of resources, time, and expertise. In short, groundwater contamination is hard to follow because it's underground, moves slowly, follows unpredictable paths, and requires advanced, costly technology to detect low levels of pollutants. Understanding these challenges helps us develop better ways to monitor and protect our vital groundwater resources.